Okay, welcome to CE 529, folks. So we are just going to pick up quickly from where we left off in the lecture. So I want to wrap up that discussion. I know you're all eager to work on vSIM, but I just want to take maybe a few minutes to wrap up our discussion on the dynamic traffic assignment and instantaneous versus experience travel time. And then I did post a little homework for you, 2 problems due on Tuesday before the class. So that'll be helpful, and so that we can then start a new topic in the lab. So let me go ahead and open the lecture real quick. So I go to dynamic traffic assignment. I will show you. And share screen. Okay. One thing I was able to do is I was able to get the audio system working on this, so we don't need an extra setup with the phone or anything, so that should work. Okay, so just wrapping up the discussion on the. So we did these examples that you can see on your screens, right? In the lecture, we were trying to wrap these up. Now, next thing I want to do is I want to kind of look at it from a perspective of origin, destination, and multiple routes and all of that. Okay, so now instead of having simple linear network, you have some connections here that go from node 1 to 2 and 3, and then 4, 5, and 6. And here I'm telling you that this point is my origin point, and then this right here is the destination. And then these are all one-way links that go from origin to destination. And if you look at the node 1 being the origin, node 6 being the destination, they have sort of different travel times, and your goal is to find the shortest route between node 1 and node 6 following the instantaneous travel time. Okay. So node 1 to node 6, first of all, you have to think about how many routes do you see if these are all one-way links. So that's the first question you need to answer. How many routes do you see if these are all one-way links? To go from origin to destination, node 1 to node 6. 3 routes, right? You can either do 1, 2, 4, 6, you can do 1, 2, 5, 6, or you can do 1, 3, 5, and 6. So you have to basically solve that little problem that we were working on in the class 3 times over. So essentially you'll have to, for 3 routes, you have to give me instantaneous travel time and experience travel time. So that's your 6 answers. And then you have to do these calculations for departure time 1 and 2. And your homework is basically this exact problem, other than the fact that your departure time is going to be 3 and 4, rather than 1 and 2. I want to work on the 1 and 2 in the class right here. And then I want to work on 3 and 4 with you. I'm going to have you work on 3 and 4 for the homework. So let's think about t equal to 1. Let me sort of work that out with you. Okay, for instantaneous, and then work it out for experience. And then I'll give you a few minutes to work on t equal to 2 problem. And then make sure that everybody understands that. And once you've gotten over that hurdle, we can move on to, you should be able to solve your homework problem. Okay. So let's think about, if you're starting at t equal to 1, I'm going to first start with route 1, 2, 4, and 6. Okay, so I'm going to start writing. I'm going to do slideshow. I'm going to start annotating under some text. So I'm going to do it first for route 1, 2, 4, 6. I'm starting at t equal to 1. I'm going 2, 4, and 6, and I'm still doing instantaneous travel time, by the way. So I'm doing instantaneous travel time. So if I'm doing instantaneous travel time, I'm just going to look at t equal to 1. I look at all of those things at t equal to 1. So how much travel time would it take me to get to node 6 based on instantaneous travel time calculations? So I don't worry about updating my travel time at each individual nodes here anymore. I just look at, okay, t equal to 1. When I'm leaving the node 1, I think, okay, it's t equal to 1 minute on this route, 1 minute on this route, and 1 minute on this route, because that's all I care about in the instantaneous calculation. At the time of start, what's happening on each route? Give me the travel time. I'm going to add them up. So it's going to be just 1 plus 1 plus 1 equal to 3 units of travel time. Or 3 minutes, whatever you want to call it. Now let's see if I want to do 1, 2, 5, 6. For 1, 2, 5, 6, what is going to be my instantaneous travel time to go from 1 to 5 to 6? So I'm going to again look at individual nodes. It's right now at t equal to 1. It's taking 1 minute on node 1, 2. It's taking 2 minutes on node 2, 5. And it's taking 1 minute on node 5, 6. And remember, I'm not doing experience travel time. So I'm just doing instantaneous calculation at the time of start at my origin point. Okay. So I'm going to just do 1 plus 2 plus 1, right? Is that right? So that gives me 4 units. Now I want to do 1, 3, 5, 6. Easy enough. 1, 3, 5, 6 should be easy enough as well. I just look at what's happening at t equal to 1 at these different links. What 3 numbers do I add up? Oh no, I made a mistake here, right? No, I didn't. Okay, that's all good. Okay, what happens in 1, 3, 5, 6? That's exactly right. I'm going to just do 2 plus 2 plus 1. I got 5 units. And now these travel times are good because now I can, if I'm routing traffic, let's say I'm doing all or nothing assignment, then I can assign all traffic to 1, 2, 4, 6, right? So these things could be done now if I wanted to. And I'm not going to actually, we're not going to get into assigning traffic at this point. We're just understanding these instantaneous and experience travel time routes. Okay, now let's do, because our next problem actually is about experience travel time. And although it doesn't say that on here, but if you go to the next slide, it talks about the experience travel time. So let's do experience travel time for and I'm doing this calculation for t equal to 1. And I'm now trying to do experience travel time calculations. I'm trying to do the experience travel time. Okay. Very good. So I'm trying to do the experience travel time now. All right. So I'm now trying to do the experience travel time. And I'm going to start at t equal to 2. Or sorry, t equal to 1 rather. And I'm going to still do 1, 2, 4, 6. And I should probably not do this big. Okay, so I'm doing experience travel time 1, 2, 4, 6. Starting at t equal to 1. What 3 numbers do I add up now? What will be my individual travel times on each of these links? What will be the travel time on link 1 to 2 if I'm starting at t equal to 1 and I'm trying to do experience travel time calculation? 1. So I'm going to add 1 because Okay, I'm going to add 1. And then what happens in 2 to 4? Now you have to start thinking about what time do you arrive at node 2? What time do you arrive at node 2? T equal to 2, right? So then how much travel time occurs on link 2 to 4? 2, right? Because you're arriving here at T equal to 2. That means you will spend 2 minutes or 2 units of time to go from 2 to 4. So I'm going to add, in terms of my travel time, I'm going to add 2. And I arrive here at T equal to 1, 2 to 4. So I arrive here at what time now? I started at T equal to 1. I've taken 1 unit of time to get to 2. I've taken 2 units of time to get to 4. Okay. So I'm here now at T equal to 4. What happens next? To go from 4 to 6, what do I need? 6 minutes, right? So I need to add 6 units of time to my travel time. So my travel time now would be 6 plus 2 plus 1. It's 9 units. If I'm doing experience travel. Okay. Let's do it for 1, 2, 5, 6. And by the way, you don't have to add up these 3 numbers either. You could have just done, just if you can keep track of it, you start at T equal to 1, you get here at T equal to 2, okay? You take 2 minutes on this line, you get here at T equal to 4, and then you get here at T equal to 4, is that right? Yeah, 1. You get here at T equal to 4, and then you take 6 minutes on here, you get here at T equal to 10. Okay, and then you can do 10 minus 1. The end time minus the start time should give you the same answer. Okay. 1, 2, 5, 6. Let's do 1, 2, 5, 6 real quick. And let's try to match it up. So I'm going to pause the recording. So the answer that I'm seeing from the students is 5 minutes. Let's confirm this, 1, 2, 5, 6. So if I'm doing 1, 2, 5, 6, I start at T equal to 1, I get here at T equal to 2. And then I go, okay, from 2 to 5, I take 3 minutes. Okay. 3 minutes, I get here at T equal to 5. And then T equal to 5 takes 1 minute over here. So I just need to add 1 plus 3 plus 1. That's 5 minutes. That's exactly right. So I'm going to add 1 plus 3 plus 1. Oops. Oh, it isn't. 1 plus 3 plus 1. 5 units. And that's good. Okay. And then I can also do last one, 1, 3, 5, 6. And what does that look like? So 1, 3, 5, 6, we start here, 1, T equal to 2 minutes on the first link. Then you add that time, you get here at T equal to 3, 1, 2, 3, you take 1 minute on the next route. You get here at T equal to 4, and you take 1 more minute. Questions? Does that make sense? 4 units. Okay, so you can see the instantaneous calculations were really simple because you were just taking at the time of the start. And in experience travel time, you have to sort of go each node by each node. Yes, I see a hand raised. Yes, please go ahead.
Oh, yes. Is it not from 1 to 3 or?
Oh, pardon me, what did you say?
From 1 to 3. Is that 1 minute or is it 2?
1 to 3. You 1 to 3, it's 2 units, right? That's what I have here. Because if you're starting at T equal to 1, it takes 2 minutes to get to route 3. I mean, node 3.
Oh, got it. Yeah.
Yeah. So I know it's a lot of little things to track. So the question was, what was the travel time from node 1 to 3? It is actually 2 minutes because you're looking at this bottom box right here. Okay. Questions? All right, so this is basically the problem right here. Okay, and then you could do it for number 2. Your homework basically says for number 3 and 4. So what I'll do is, like, I'll give you 5 minutes to make sure that you can do it on your own. Now repeat these calculations for me for instantaneous travel time t equal to 2 and experience travel time also at t equal to 2. You start at t equal to 2 from your origin point. Okay, and your origin is node 1, of course, and destination is node 6. Okay, so let's take, maybe it's 12:30 right now, so let's take maybe 5 minutes to do it. And then let's come back. I'm not going to go over that solution because I know you are capable, but let's come back and talk about it if there are any questions. So do both instantaneous and experience, but instead of starting at t equal to 1 at the origin, start at t equal to 2. Is the question clear? Okay, wonderful. All right, so let's hear some answers. I put in the instantaneous travel time calculations. 1, 2, 4, 6. I got 6 units, right? Is anybody got different? Please let me know because I make mistakes all the time. So please let me know if you got a different answer. We have to make sure that we got it correct. So I got 1, 2, 4, 6, 6 units. Again, just instantaneous. 1, 2, 5, 6. I got 6 units, and 1, 3, 5, 6. I got 5 units, right? Everybody got that? That seems to be the trend. Okay. Now do experience. I just did 1, 2, 4, 6. It was, I didn't want to do the other two, but let's see. 1, 2, 4, 6. 8 units. Does that look right? Be very careful because I might have made a mistake. So if you're not getting 8, please raise your hand. We need to make sure that this is correct. If you're getting 8, then we are in good shape. Okay. All right. So I'm just going to quickly do 1, 2, 5, 6. What is there anybody who got some numbers for 1, 2, 5, 6? 5 units, and then 1, 3, 5, 6. 1, 3, 5, 6. 3. Okay, so I'm just going to put it down. Let's check it out. And then, of course, these numbers, some of the times these numbers might assume that these travel times sort of continue beyond. Like if you need it, then the travel time always remains 1 unit as you sort of get ahead in time. Okay, so let's verify this 1, 3, 5, 6 first. You're starting at t equal to 2 here. It takes you 1 minute because at t equal to 2, it's take 1 minute to get to link 3. So you get here at t equal to 3. It takes you 1 more unit of time to get here. T equal to 4, you get here. And then it takes you 1 more time to get here, t equal to 5. So you are here at t equal to 5 at your destination. You started at t equal to 2. So your travel time would be 3 units. And I know I'm using a different calculation now. I'm just doing that, getting to the end point and then subtracting the original starting travel time. Okay. And then same thing with 1, 2, 5, 6. 1, 2, 5, 6. It's you start at 2. You get here at 3. Right. If you get here at 3, it takes you 3 more minutes to get here. You get here at t equal to 6, and at t equal to 6, it takes you 1 more minute to get here, t equal to 7. And so your travel time would be, you reach your destination at t equal to 7, you started at t equal to 2, so you get here at t equal to, your travel time was 5 units. That's what that. Okay, so I'm glad everybody sort of got that. That's wonderful, because your homework is almost exactly the same problem, but now you're going to do this repetition for t equal to 3 and t equal to 4 start time. Okay, so let's go ahead and not do right now, but make sure that you guys work on it. And I want to remove this. Okay, so that's that for this one. And then next thing I want to talk about is real quick. There's one more problem in your homework. So if you go back to your 529 class, I've made available the homework. Okay, so if you look at this homework 3, that's due on the 19th. So this is that one problem here. And then the other one is basically a route problem, a simple one, essentially the same one that we discussed in the class. Now you have 3 routes. You are supposed to determine the user equilibrium flow on each route. Okay, so this is essentially the same problem that you solved for homework 1. But the second one has a twist there. Repeat the problem considering if the routes between the OD pair they were part of a larger network and they had certain pre-existing flows. Okay, So this is the discussion we had in the class the other day. So make sure that you sort of pay attention to that discussion and then solve this problem. And again, all of this is due on Tuesday. I do have office hours on Monday, so if you have questions, you let me know. And of course, if you get into the lab today, you're welcome to ask any questions about these, and if you want to work on it. Okay. Yes, please.
For the second problem, do you want us to give the answer in like the x1 or like the x1 prime?
So yeah, I need the user equivalent flow on each route. So I'm looking for the total flow. Okay, I'm looking for the total flow that will exist on these routes. So I do need that total flow. And once you know the total flow, you can easily derive the new flow as well. So yeah, actually for me, either answer would be fine as long as you get them correct and you know what you're getting at. That would be fine. That's a good question as to how you want to express those flows. Either you want to express them into equilibrium flows between the OD pairs or the total flow that will exist on the route. So I'm going to say, obviously for the first part, they're both the same because there is no pre-existing flow. But for the second part, either one would be fine as long as you clearly mark what it is. Okay, thank you. Okay, so